So my name's Wayne Pekarski, and I'm a developer advocate at Google. And so today we're going to be talking about sort of developing applications for Android Wear. So we're going to do a bit of an introduction to how Wear works, and then we're going to get into some of the real nuts and bolts of the Wearable support library, some of the things that make developing for Wear unique. So as I said, I'm a developer advocate at Google, and I work mainly in the areas of Android and ubiquitous computing. So we work on a lot of the new form factors that Google's working on, such as wearables and auto, and Brillo and Weave and so forth. So we're doing a lot of those things like that. So that's kind of what I work on. And another thing I'm really excited about is I'm at this Android barbecue, so I was like, well, you know what? I should share my breakfast sausage recipe with everyone as well. So here's my little recipe for it. And if you go to my Google Plus page, which is google.com/+WaynePekarski, you can see my recipe. Now, this is like my favoriteest breakfast sausage I've ever worked out how to make. So you can use it for chicken fried steaks, biscuits and gravy, and it's really simple. You take your own ground pork and you mix it up, and then you fry it up in a pan. You got to make sure you use a non-stick pan. You got to use one of those old school pans, like a cast iron skillet or something like that. And then you put some flour in there and you make a roux. And then when you're done, you can pour it over biscuits and gravy, or you can put it on top of a chicken fried steak, or all those kind of things. So, yeah. Anyway, so that's my talk. So I guess we're done now. So I guess we can all go home, right? But yeah. So I figured since we're at the big Android barbecue, I probably should share that with you. All right. Let's get back on track here. So we're going to talk about Android Wear today. So look at this picture here. We've got a bunch of people standing around, and they're all looking at their phones, and they all appear to they're kind of disengaged from each other. And we see this a lot nowadays. Like, people go out with their friends, and no one's actually talking to anyone. They're busy on their phones doing stuff. And so we've been looking at this kind of usage, and we're like, well, what can we do to make things better? So we know that phones and tablets are useful, but it seems like we're disconnected from the people around us. So Android Wear aims to sort of complete that picture. And you can see here in this photo, everyone's happy, having a great time. This is what happens when you use Android Wear. Anyway, just kidding. What it does is it helps you stay in the moment with the people that are around you. So it keeps you in the moment when it's appropriate, but it gives you the information you need when you need it, and it tries to avoid the distraction of pulling your phone out of your pocket and constantly being distracted. So let's look at this in a different way. This is how it looks like when you use your phone on a day-to-day basis. You're doing real life, then something happens, you pull your phone out, you unlock it, you read some notification, oh, okay, and then you go, oh, there's a news article, I'll start reading that. And the next thing you know, 5 minutes of your life has disappeared, and there's this huge time and attention cost that it's imposed on you to be able to use this kind of thing. So you might want to be distracted in your device, but you also might be very busy amongst your friends, and this isn't really what you want to be doing. So with Android Wear, we're attempting to change that. So there's your day, chugging along, something happens, you quickly look at your watch and go, oh, cool, I better take that. Or, oh, it's not that important, I'll skip. So it allows you to have a quick look, a quick glance at your watch. It has an always-on display that's always showing something, and it helps you to reduce the overhead of being notified about things that are going on in the real world. And so it allows you to be more present in the real world, but yet more connected to the virtual world with the things that are important to you. So what does this mean for your development of apps? So to start with, it's a very different interaction model. So with Android Wear, you can see we have a range of different devices. There are round displays, there are square displays, the screen's really small, and if you want to get a really good user experience on wearable devices, you really need to rethink the way that you program for it and the way you use it and everything else. So one thing people like to do is they like to say, well, I'm just going to take my phone app and sort of jam it onto the wearable screen and make it really tiny, but that's not really what you want to be doing. So the way you should think about designing apps for wearables is to say to yourself, what couldn't we do on the phone that a wearable device now makes possible? And that's the kind of app you should be building. And I think the killer app for wearables in general is coming, and it's going to be made by one of you people here, a developer who's like, you know what, I have this really amazing idea, and it's going to change the world. When Android and iPhones came out many years ago, everyone thought they were just going to be browsing the web and checking their email. And now we've got all these exciting apps that people use that they couldn't live without. Those are the killer apps that define the platform. And so the killer app for Wear can be created just by you because it's an open platform. And the next thing is that when you build a wearable app, you have to actually try it. So you can't just run it on an emulator on a massive desktop screen with a mouse. You have to actually put it on your wrist and go for a run. And while you're jogging, you should try to use your app by touching the screen. That's when you'll discover if your little buttons are too small or if there's some kind of problem with how you're doing things. So you got to get yourself in the situation and try it just like a user would do. And so these are things that make Wear different. So this here is the Android Wear interface. And so you can see that we have, there's no grid of icons to launch. It's simple, it's glanceable, and it's built around micro interactions. These very quick little gestures. You can look at your watch in the corner. You don't have to use it like you do with a phone. And the interface is divided up into two primary behaviors. So we have the ability to talk to the wearable, use your voice. You say, okay, Google, send a message. So you talk to the phone, you talk to the watch to make it do things. And so we call these actions. And then the next thing is that once you say, okay, Google, it then shows you a list of commands that are possible. So you can do things like take a note, call me a ride, things like that. And these are the things that are available to you. Now, the wearable can send information back to you as well. So we have these notification cards that pop up. So we call this the context stream. And so there's a variety of different things that the wearable can send to you to show you on the screen. Are you ready for the trip? You have a flight to JFK coming up, your hotel information, things like that. This is stuff that you're walking around and your watch will vibrate and you're like, I've got to get to the airport. So it's telling you things that are important right now in the right place. We don't want to tell someone about something that's happening 8 hours from now. You want to tell them about something that's right now and it's important. So this is the framework that helps you to set you up for success on Android Wear. So if you want to make a really good application, you have to carry this philosophy into your apps as well. So for example, you have to build wearable apps that are aware of the user's context, their time, their location, their physical activity. That card there is aware of the fact that it's going to take you 15 minutes to get home right now because you've put something in your calendar that tells you that you need to be home by then. A watch is also designed to tell time in a split second. So when a user uses traditional watch, they just look at it, know what the time is, and they're done. And during this talk, I'm going to glance at my watch multiple times to find out how I'm going for time. And so it's very quick. You're not seeing me pulling my phone out and unlocking it and checking the time. And so if you can check the time in a split second, you should also be able to check whatever's going on in a split second. So here it's like turn right onto Washington Street. This is a direction. Right now, this is something you have to do. And it's very quick and easy, and there's an arrow pointing to where you need to go. You can think of Android Wear as kind of like a personal assistant. You ask it to do things, and it does the right thing for you, and it just gets it right. So here it's got, send a note to Jeff, I'm on my way. So these are very simple actions you want, and it would be the kind of thing that if you had a friend next to you, hey, can you send a message to Jeff, tell him we'll be there in 5 minutes? That's something your friend could do for you. It's a personal assistant that's designed to help you. And finally, you've got to focus on very simple interactions. You've got to only require input when it's necessary. You should try to do the right thing automatically. And most inputs are going to be done with touches or swipes. And because the screen is very small, you have to make sure that you've got very large touch targets, things that are easy to click while a person is running, like we talked about before. So you want to avoid fine-grained finger movements. You don't want to have tiny little keyboards and things like that. So when you design your Android Wear experience, you've got to keep these kind of things in mind. So with that, now we're going to talk about the nuts and bolts of how we go about building applications. But I really wanted to sort of set the stage for how this works because it helps to understand that with Android Wear, the UI is probably the most important thing. How it interacts with the user is everything. You can't write good code for this until you've seen how it works. Excuse me. All right, so let's go through 3 topics now. We're going to talk about how to do notifications, how to make your own watch faces, and then how to design your own full-blown apps that run on Wear. So the first is notifications. Now the cool thing about notifications is that if you have a notification on your phone, they're automatically sent over to the Wearable by the Wearable Companion app. So any standard Android notification works for free on Android Wear, and you don't really need to do anything. Now you can extend them to add features, but you don't need to. So to get this done, there's no work required. They're just automatic. Also, if you've implemented the media APIs or remote control client, the actual controls for those are automatically sent to the Wearable as well. So any standard music playing app when you're playing music on your phone, you'll see a notification on your wearable that you can use to change tracks, pick a different song, and things like that. And to get this done, once again, no work required. Now, if you want to implement slightly more complicated notifications, we have some extensions that we've added to notifications. So we have stacks, pages, and replies, which allow you to make slightly more complicated notifications that'll appear in a special way on the wearable, but they'll still be regular notifications on a phone. And you can add these features, and it won't break your app, even if your app is needed to run on a gingerbread phone or something like that. So these extensions allow you to add a little bit more to your notifications to make them slightly more useful. The really cool part is you don't need to do anything to your app except adding a couple extra lines of code in your notification section, and your app is already sort of on the way there for Android Wear support. So that's a really nice thing about notifications. Later on, we're going to talk about how to write full apps, which are a very complete Android Wear experience. This is a great way to get started. So if you're already an existing Android Wear developer, you can easily add some quick Android Wear support, have a think about it, try it out, and then you can go the whole way if you decide that's important for you. So watch faces are probably one of the most exciting things that people love to talk about. So you can see we've got a watch. The watch face is the screen that is running on the watch all the time. So when the user is not using the screen, it is showing the watch face. And you can load many different watch faces onto a device. You download them via the Play Store. And it's probably the most important part of a user's Android Wear experience. And you as an app developer have the ability to make your own watch faces of any kind, analog, digital, whatever you want. And so this is something that people are really particular about. People like a watch face that's designed for them. I like a digital watch face I like a digital watch face in orange. A lot of people don't. They like analog watch faces. So everyone's got a different taste here. So there's a lot of opportunity to make some really cool watch faces that really change the way we tell time. So I'm going to talk to you a little bit more about the APIs that are used to do this. So with a watch face, of course, the most important thing is that it has to actually tell the time. So make sure you always have that. It would be kind of silly to make a watch face that, I don't know, shows a cloud on it saying it's raining outside, but doesn't actually tell the time. So people are probably not going to like that. So you've got to make sure you put that in. So you can use analog hands, like in this case, or you could put a digital representation on top of it. Or you could use some other kind of representation, like you could print it in binary or hex or whatever it is that you think your developers want. So you can do that too. Now, there's a status bar area, so you can see we've got a little alarm bell with a stroke through it. That's telling you that notifications and alarms have been suppressed. So these are going to be put on the screen by the system, and you need a place on your screen for those to appear. So you can own the whole watch face and draw what you want, but the system also needs to put a few icons here and there that you need to make room for. And also, notification cards are going to pop up in the stream on top of the watch face. So you need to be prepared to deal with them. So what you can do in some cases is you can resize your watch face to not be under the card. In other cases, you can also control how much the card pops up and things like that. So you get control over all these things as part of the API for it. And you can also add other things such as the time of day, the current weather. A lot of the Android Wear watch faces that are out show things like showing details from your calendar, showing the weather, the tides, the moon, whatever you want. So you can have different watch faces for different kinds of people depending on what they want to do. So here are a few guidelines to make sure you get this right. So the first thing is that Android Wear comes in multiple form factors. So if you're designing a watch face, you really want it to run on both round and square watches. So it would be kind of a bad idea to build a watch face that only runs on square, and if round people install it, it doesn't work. People are going to be upset. They're going to write bad reviews about your app. So you really want to make sure you cover both platforms. And in some cases, like an analog watch face, if it's just got some hands on it, that'll work both on a round and a square device. In other cases, you might have to redesign the watch face completely because square is very different. The corners are present, whereas on a round watch, they're chopped off. So you might need to deal with that. Next, Android Wear displays have two modes that they run in. There is an interactive mode and an ambient mode. So interactive mode is when you're touching the screen and you're interacting with the device. You can actually detect touches as well. And this is the mode that's used when the user is giving their attention to the watch. Now, the screen is fully active. You can have all the colors and everything like that. But after a short period of idle time, the watch goes into what's called ambient or always-on mode. In this mode, the screen goes into a low power state, it reduces the amount of colors that are available, and you should also reduce the number of pixels that are drawn on the screen to save power and to avoid burn-in. We'll talk about that a bit more in a sec. But you'll see in this case here, we have a watch face on the left, which is full color, and then in ambient mode, it's just a black screen with hands on it. So you need to design your watch face to run in both of these modes, and you cannot render a full colored image constantly in ambient mode when it's sleeping. The watch won't allow that. And secondly, the watch face refreshes continuously when you're in active mode, but when you're in ambient mode, the watch goes to sleep and it only refreshes the screen once every minute. So you should remove the second hand and you should only draw hours and minutes because we're trying to save power. So when the screen is in ambient mode, the watch is not running. It's actually asleep, and the only thing that's awake is the display driver just keeping that screen going. So it's a great way to save power, and it means that you don't have to flick your watch up to look at the time. The watch is always showing the time. As you can see from as I'm walking around, this watch never shuts down. And that's one of the really cool features of Android Wear, is the screen is running all the time. Now, when we talk about ambient mode, we also need to deal with how it's implemented. So for example, certain screens on Android Wear are called low-bit screens. When they go into ambient mode, they actually don't allow full 24-bit color. They only allow primary red, green, and blue colors. Like, only certain colors are allowed. You can't render shades and all that kind of thing. It's a feature of the display driver that allows it to save power. Other displays go into a black and white mode, and some displays, such as OLED displays, actually require you to only illuminate 5% of the pixels in low power mode. If you try to keep all the pixels on the screen on all the time, what will happen is that over time the screen will burn in and you'll actually you'll see the pixels permanently burnt into the screen. And the other trick that some of the displays do is they'll actually take your watch face and every minute they will jiggle it in a direction. So they'll jiggle it 10 pixels in either direction, and they use that to help the watch face avoid burning your screen in as well. So you should never have large patches of solid color because they will eventually burn into the screen, and the jiggling can't get around that either. So definitely you want to try to make sure that you're careful about when you design your ambient mode, because you need to keep a lot of the pixels off to save power and to save the screen. So when you're writing a watch face, there is a class called Canvas Watch Face Service.engine that you're going to be sort of implementing here. And inside of that, there is 3 methods. So there's onCreate, which is where you're going to take care of initialization steps. So one thing you want to make sure you do here is you can have an image as the background of your watch face, but you've got to make sure that you scale the image and do anything like that in advance. You don't want to be scaling the image on every redraw because that's very expensive. You'll generate a lot of memory and so forth. So in onCreate, you want to do all of the initialization steps. The next thing is there's a method called onSurfaceChanged. And onSurfaceChanged is called when it announces the size of the screen to you. So this is where you would deal with things like resizing an image or anything. I guess it's possible in the future that a watch could rotate, and if it rotates, it would give you an update on onSurfaceChanged. So onSurfaceChanged is where you're notified as to changes in the screen. And then finally, all the drawing itself is done in the onDraw method. So this is the method that's called by the Android Wear system that says draw the watch right now. And so you should be doing no calendar queries. You don't want to be doing anything expensive. Everything has to be fast here. And that's where you draw everything. And if you want, you can have an animated watch face with smooth ticking second hands. So no ticking, it'll just smoothly move by just repeatedly calling onDraw over and over again. And then you call an invalidate method, which then makes it call onDraw repeatedly. But you don't want to be doing that kind of work when you're in ambient mode, because you want the display to sleep and you don't want to be constantly hammering away trying to refresh the screen. So when you're in ambient mode, your app needs to stop doing things. You don't want to be doing you don't want to be doing any work. You want to be sleeping while the watch is in ambient mode. So that's watch faces. Now let's talk about how we go about actually building apps and making them work on Android Wear. So Android Wear devices are actually complete Android implementations. They have everything. They have OpenGL. They have all of the activities and frameworks and everything that you've come to be used to writing regular Android apps. Probably the only 2 things that are missing is that there's no video codecs and you don't have direct access to the internet. So you can't make HTTP requests to a web server, and you're not able to play video back on the screen. The codecs have been removed to save power and battery and space on the device. And you also probably shouldn't be playing videos on an Android Wear device as well. if you're looking at something for 30 seconds on the screen, like watching a video, you probably should be pulling your phone out of your pocket and looking at it on a regular screen. So there's certain things you really don't want to be doing, but Android Wear devices are very powerful and they're capable of doing pretty much anything you can throw at them. The only difference is the way they're packaged. And so the way it works is that you build a wearable APK that's going to be installed to the Android Wear device. But the wearable APK is not sent directly to the wearable. What you do is you take the wearable APK that you've built and you put it inside the phone APK. You put it in the res raw directory, basically. When it's in the res raw directory, you declare an XML file, and then you put it inside the main phone APK and you push that phone APK to the Play Store. When the user downloads that phone APK, it arrives on their phone, and then the wearable companion app goes, oh, there's a wearable app in here. It takes that and installs it onto your wearable, and then it installs and it's ready to go. So the nice thing about Android Wear is that over time, as different companies add Wear support to their apps, your customers just kind of get it for free. They don't need to go out of their way to download a new app or to go and check any boxes or do anything. It just happens automatically. So that's the great thing about Wear, is it's very easy for customers to deal with. So one final thing is that when you update your app to the Play Store, you bump the version codes, you push it onto the Play Store, and then it downloads to the phone, and then the phone goes, there's a new version of the app. I'll push it to the wearable as well. So as a little tip, very important that you get the version codes on the wearable and phone sides to be the same. They have to have the same package name, otherwise they won't be able to talk to each other. So in Gradle, in Android Studio, we have a Wear app. So you'll see this in the build.gradle for the application. It'll say Wear app, project, brackets, Wear. And what that says is take the wearable project, compile it, and then bring that APK and put it inside the phone app. So it actually takes care of all this for you. So when you're building in release mode, the wearable APK is embedded into the phone APK, just takes care of it for you. And a lot of our samples implement this as well, so you can see how it's done. So let's talk now about things that are wearable specific. So while they are complete Android devices and they implement everything that you've seen on Android before, so you can reuse your same skills and knowledge, there's a few things in Android Wear that are different that you need to be aware of. So the rest of the talk is going to be talking about those things. So we're going to talk about sharing data between the wearable and the phone. We're going to talk about building custom user interfaces. And then we're going to finish up by talking quickly about how we implement voice interactions. So as I said before, Android Wear devices don't have direct network access. You'll sometimes see them that Android Wear devices support Wi-Fi and Bluetooth. And if the Android Wear device is connected in a certain way via Wi-Fi, sometimes there's access, but you can't rely on that behavior. The only way to get proper connectivity between the phone and the wearable is to use what we call the data API, message API, and so forth. And what they do is they allow the wearable and the phone to talk each other, and then the phone can go and do the network access for you. So if your wearable app needs to go and find out what the weather is, the wearable app will send a message to the phone app saying, hey, tell me the current weather. The phone will then make an HTTP request to a weather website. It'll download the weather information. It'll then go, the temperature today is 56. It'll then take that number, send it over as a message to the wearable, and the wearable can then draw it. You don't want the wearable doing lots of heavy work. If the wearable is able to make an HTTP request, you don't want it sitting there making the query, parsing all the HTML and cleaning it all up. You don't want the wearable doing these kind of things. So that's important. And this communication mechanism is implemented via Google Play Services. So Play Services provides the framework that allows these devices to talk to each other, and they're done via synchronous calls. So we're going to go through now how to go about doing this. So there are three kinds of data exchange that are possible. The first one is the Node API. And what this does is it tells you when two devices are connected. So if a wearable and a phone appear close to each other, the Node API will say, yeah, a device has just become connected. And if the wearable goes off for a walk or the phone goes for a walk, then you'll get a disconnect message so that you know that they're no longer paired to each other. We have the message API, which allows you to exchange low latency messages. So these are messages where the phone might say, hey, wearable, make a noise or do something right now, and the wearable will do it. However, if the wearable is disconnected, that message will be lost. So you only use messages in cases when something has to happen right now, but if the message is lost, it's no big deal. So they're kind of like UDP packets when you're doing TCP/IP. And then we also have the data API. The data API allows you to create like a key value object that has something like temperature 56, current weather, raining. You can put that in an object, and then you can send it to all the wearable devices on the network, and it'll automatically synchronize it for you. And you don't need to worry about retransmitting. If the wearable is not connected, when you bring it back later on, the messages will be, the data items will be synchronized up. It takes care of all those things for you. So it's really nice. And actually, we have another API called the Channel API, which allows you to make connections to a wearable and send data over it. So you could stream some audio or something like that. So there's a variety of different APIs that we provide to allow you to communicate back and forth from a phone to a wearable. So to quickly walk through it, this is the node API, so you can see here where there's a get connected nodes method. You call that, it returns you a list of all the wearables that are connected. An important tip here is that it's possible for users to have many Android Wear devices connected to a phone. So when you get an array back from that top call, you should not just read the first element. You should read all of them, because some people like me have 8 Android Wear devices at their desk, and I want all of them to work all the time. So make sure you code that up for me, otherwise my functionality won't work. So yeah, people can have many Android Wear devices. That's a very key sort of mistake that some people make, is they don't do that right. And then you simply declare a node listener, and you get these methods that are called when peers are connected or disconnected. For the message API, we have a method called sendMessage. You simply pass in the ID of the device you want to send a message to. You can pass in a string, you pass in a byte array, it sends it to the device. And then you can register a method to be called on message received if a message arrives at your device. And finally, for the data API, you've got put data items and get data items. Those allow you to put data items into the store. They're synchronized back and forth, and then you can retrieve them back if messages are sent to you. And then there's on data changed, which is called whenever an item has arrived off the network. So it's a very simple API, and it helps deal with all the complexities of sending data back and forth between wearables and phones. And finally, there is a base class called Wearable Listener Service that you implement, which is what you put all those other methods into. And you have to declare it in your Android manifest XML file. And that tells Google Play Services that it is allowed to send these messages and data items to your app to allow them to communicate with the wearable. So that's basically it for sending data back and forth. So it's a very powerful API, and it's how communications are done. And as I said before, make sure the package names and the version codes and all that match between the wearable and the phone application. Otherwise, they won't be able to talk to each other. And it's not possible to send data items or messages to a different app on the system that doesn't match your package name. You'll have to come up with some other mechanism to do that. So we've talked about sending data. Now let's talk about how to build custom user interfaces on Android Wear. Because while Android Wear is based on Android, if you actually look at the user interface on the screen, it doesn't look a lot like Android. It looks very different. The interface has been designed to look great on wearables in outdoor and environments when you're walking around. So to do this, we provide a library called the Wearable Support Library to help out with this. So in your Gradle file, it's called com.google.android.support::wearable. And this is what we call the Wearable Support Library. So this Wearable Support Library provides functionality that's specific to Android Wear devices, but that doesn't belong in the Android framework itself. So when we designed Android Wear, we wanted to have a common experience across the platform so that apps look the same. So we wanted system apps and apps written by developers like you to have a consistent look and feel. And so this library contains reusable UI elements that you can use in your code to make your life easier so that you don't have to reinvent the wheel. So we use this library for our apps as well. And so if you've actually got any ideas for things that are like, I really wish I had a widget to do blah, please come and tell me or one of the other developer advocates, because we'd like to hear more feedback about the kind of things people want. So what is the Wearable Support Library and how does it work? It's different than the Android Support Library. So you might be familiar with the Android Support Library. That is used to sort of backport new Android features to old releases. The Wearable Support Library is different. It's designed as a general support library that these are things that might never make it into the framework, but they're useful for designing wearable apps. The next thing is that it's compiled statically into your app. So if you do use the Wearable Support Library, the code is going to be in your APK. It's not part of the system itself. So your APK is going to get a little larger when you use it. Now, you can strip out the parts you don't need with resource minification and ProGuard, but just be aware that that has to be done. So it doesn't have a huge impact on your APK. The actual library itself is quite small, so it won't cause too much bloat in your APK, but it's something to be aware of if you're working with it. It's also released at different cycles that are independent of the Android framework. So the Android framework is like Marshmallow, Lollipop, KitKat, things like that. The wearable support library is independent of that. It typically is released whenever a new Android Wear release comes out. So it's not changes to the wearable support library are not dependent on new APIs coming out. So that's nice. So we can add new features and we can fix bugs very quickly. And this library, though, because it is a new library that's statically linked in, the API actually could change a little bit between versions. So there's a possibility that if you bump to a different version, you might have to tweak your code a little bit, but you can always use the old version if that's what you want. So you need to be aware of the fact that the API could change and it might break backwards compatibility. So it's not like the Android framework in that we guarantee that it's going to work till forever. The wearable support library will evolve over time. So how do we go about using it? So when you're writing your build.gradle file on the wearable side, you've got the dependencies section. So if you look at the bottom, you can see it's got Play Services Wearable. So some of you may have used Google Play Services before. That's a pretty standard kind of line that you include that says, give me Play Services - Wearable. Play Services has actually been broken up into pieces so that you can select which parts of Play Services you want to import. Because Play Services is a very large library, and you don't want to import all of that into your app. By just adding Play Services Wearable, you're saying, I just want the data API, and I just want the message API and things like that. The wearable support library is the top line. So we've said, okay, com.google Android support wearable, include that library. And then we have a plus at the end. Now, some people would say you should never use plus because what it does is it grabs the latest version of the wearable support library. So you could be in the middle of a release, and then that day Google releases a new version of the wearable support library, and you're like, why is my build broken? And it's because you said, grab the latest version. So if you want stability with your builds, you should hard code in the version number. So if you look on the Play Services at the bottom, I've got :8.1.0. And that says, use version 8.1.0, and I don't care what the newest version is, you must use that version. So right now, wearable support is 1.3, but you can hard code that depending on what you want to do. I have some test samples that I use that have a plus in them because I want to always test with the latest version to see what's going on. But you can control what happens here. But it's very important that you understand the implications of plus versus a version number. And this is a common thing you need to understand when you're writing any kind of Android app. And finally, the middle line that says provided, that is needed for when you're implementing the always-on mode. We have a special library that helps out. You'll need to include that line. I won't go into too much detail on that, but that's also important as well. So when we introduced Android Wear, one of the big differences was that it had a round screen. So up until then, every computer and everything we've ever had has been square or rectangular displays. So the introduction of a round display is really beautiful, as you can see from these watches here, but it imposes challenges for developers because people haven't thought about round screens before. So widgets we're using like text view and things like that, they don't understand round screens. So we need to help developers understand how to deal with round screens and then what we can do about it. So if you look on the left, you've got the Moto 360. That actually has an inset at the bottom, or what some people call a chin or a flat tire, which is 30 pixels in size. You've then got the next watch, which is a square screen, even though it looks rounded. The next one is a round screen with no inset. And then finally, the last one is a rectangular screen as well. So we need to write software that works on all of these screens. So if we were to create a text view and put a large amount of text on the screen, what would happen? On the far right, you can see we've got a regular rectangular screen. The text fits nicely. However, on the round screen, you can see the top, bottom, right, left, everything is all chopped off. So you can't read all of the text. So it would be a really bad idea to throw a pile of text on the screen and not do anything about it, because all of your round customers are going to have a bad time. And there are a lot of Android Wear round devices out there. So if you only design for square, you're not going to do well. Like, people are not going to like your app. So what can we do about this? So Wearable Support Library provides 3 different classes that you can use to help out here. We've got box inset layout, wearable frame layout, and watch view stub. We're going to go through each of them to show how to use it. So the first one, box inset layout, what it does is it adds padding around the edges of your text view to prevent the text from touching the edges of the screen. So you can see on the left, the box inset layout has added padding all around it so that the text never touches the round edge of the display. So we can read the text, it looks nice, And that's quite cool. So how do we go about implementing this? And finally, actually, before we do that, if you look on the square screen, it's exactly the same as before. So we're using all of the space on the square screen, but on the round screen, we're making it fit. So how do we go about doing this? What we do is in our layout XML file, we have at the very top, where's my laser pointer gone? There it is. Anyway, if you look at the top, there's box inset layout. Can people see the cursor? No. Where is it? No, my cursor is not working. Oh, don't worry about it. If you look at the top there, we've got, at the top level of the layout hierarchy, we have a box inset layout. The box inset layout contains the text view, and then inside the text view, we've defined an attribute app layout underscore box equals all. Now what that says is we're living inside a box inset layout, and I want to be boxed on all 4 sides to do the implementation. And if you actually forget to put that in, it won't be boxed. So it's very important that you actually remember to put it inside a box inset layout and also to set the attribute app layout box equals all. Now you can also, you don't have to box around everything, you can actually box just the left and the right. So for example here, you can see the text is boxed only on the left and right, and it's allowed to flow completely to the top and bottom parts of the screen. And the implementation for this is we simply replace the word all with left and right. And you can also do top and bottom as well. Same here, you can see the effect on the round screen. Typically, you don't want to always do a complete all boxing. What you might want to do is have it boxed just on the left and the right, and then have it scrollable. Because the middle part of the screen is still quite usable, but you don't want to box it all completely, otherwise you waste a lot of screen real estate. So you don't want to squeeze it too much, otherwise you won't be able to read much text at all. And so here's how we do the top and bottom. Now finally, one thing you'll notice here is that when you put a text view inside a box inset layout, the green background extends all the way to the edges. Now you might want to, so the way it works is that the margins of the text view are adjusted, but not the entire view itself. So if you actually want to force the view to fit completely and have a black background or whatever the default is, you can actually put the whole lot inside of a frame layout container and then put the frame layout container inside the box inset layout. And so that's one of the things you can do with it if you want the black border instead. You might want to have other things appearing in those corners, and this will allow you to do that. So, while box inset layout is easy to use, you simply just add it to your layout hierarchy and it boxes everything for you pretty much automatically. It's not very efficient, as we pointed out earlier. So there must be better ways of dealing with this. So in one of the recent wearable support libraries, we added something called wearable frame layout. And what this does is it allows you to specify padding and attributes for things like centering or alignment, but you can specify different attributes depending on if it's a round or a square device. So you can see here, I've got, on the round display, I've got the green box is centered, I wanted 25 dp margins, and then on square, I want it to be left aligned with 5 dp margins. And you can see that they look very different on the round versus square, but the implementation is quite easy. So if you look here, in the wearable frame layout, you can see we have layout underscore gravity round is centered, but layout underscore gravity, the default version, is going to be the left align, whatever the default is. And you can see every time we've thrown a round keyword into the attribute, wearable frame layout looks at round or not round to work out what it's going to do for your particular device. So everything we just showed in that previous example is encoded here. So the nice thing is that you can have one single XML file that does layouts for round and square. You can maintain them together, and it helps sort of to simplify the process of. One problem that people commonly do is they define a round and a square layout, and they change the square layout, and then they forget to update the round layout, and they've got bugs in on round. So this helps you to avoid that problem. So finally, we have what's called WatchViewStub, which is a class that allows you to inflate 2 separate layouts that depend on whether you're on round and square. So you can see in this case here, the layouts are completely different. One of them has a gradient, the other one has a circle. They're totally nothing to do with each other, and the WatchViewStub inflates the correct layout depending on which one you want. So if you look here, the implementation is WatchViewStub, 2 layout definitions, and those layouts are defined in separate files. So the nice thing here is that you get full control over everything. There's no need to worry about trying to express both layouts in one file, but the con of it all is that you have to have two files, and you must remember to update both of them and test on both round and square whenever you make a change. Because if you get that wrong, then you'll have a problem. So those are sort of the pros and cons of the three different ways you can use depending on what your app looks like. And which one you choose will very much depend on the app that you're writing. So that's a quick little rundown of what's available to support round versus square. So what else is in the Wearable support library? So here's a list of all of the different classes that are available in there as of now. And I'm quickly going to walk through them to show you a few things that are available in case you want aware of it. So the first thing we have is that a lot of Android Wear apps have the ability to show cards on the screen, and they also use this swiping kind of interface where you can swipe sideways to see different actions, you can scroll up and down. So there's actually something called Grid View Pager, which implements this ability to create a bunch of fragments, and then you can scroll up and down through them, and then it implements the smooth scrolling effect that you see on this example here. And this image actually is taken from one of our samples called XYZ Tourist Attractions. The next thing is there's dots page indicator, which if you look at the very bottom, there are 5 little dots that as we swipe sideways, you can see those dots changing. That's the dots page indicator that shows you which page you're on. So we've written code that provides this for you, so you don't need to worry about writing this kind of thing yourself. Next, we have action page, which you saw in the previous example where we were picking actions. Action page is the full screen button with circular text that you see there. So most Android Wear notifications and apps use this kind of button with a little PNG in the middle to express things, and people are used to seeing these kind of things. So if you use this, it does all the work for you of handling the button press and laying it out, and it also gives you a ripple feedback when you press it, and it has an action label that adjusts in size depending on your screen so that it always fits. So it's kind of nice, and it gives you the functionality that you've seen in other apps without having to write it yourself. Next, we have Dismiss Overlay View. It's a common paradigm in Android Wear apps that you want to exit something, you actually press and hold on the app, and a red X will pop up. You then press the X to exit the app. So we've provided the functionality that allows you to do this. So it gives you this pop-up that offers to let you quit out. So here it is in operation, and then here's the code to do it. Now, you actually, when you use this Dismiss Overlay View, you need to suppress the ability to swipe the app away. So on Android Wear, you typically have the ability to grab the app and flick it to the right, which will exit the app. If you're using the Dismiss Overlay View to exit out, you don't need that swipe away gesture anymore. You might want to be making, for example, a map app where you need to use the finger to scroll around a map. You don't want the user to swipe to the right to kill your app. You want to use it to swipe the map to the right. So in this code here, you can see how we're creating a new custom theme which actually disables Windows swipe to dismiss. It sets it to false, and then in your manifest file, you pick the theme that you just created. That suppresses swipe to the right. Next, we have Wearable List View. You may have seen on Android Wear the ability to select from options, like the settings area uses it, the app launcher uses it. It's a pretty common concept, so we've provided this functionality so that you can provide some colors and some images, some text, and you can swipe up and down through it. So this is a very common usage pattern. You write an adapter for it, and that's available as well. Yeah. Let's just wait till we get to the end. We're almost done, and then we can go through it. We have Delayed Confirmation View. So when you send a text message on Android Wear, you say, send a message, I made a reservation at 7:30. It then brings up this dialog that shows a ticking down timer that shows that it's about to do it. So the nice thing about this is if the user does nothing, the message is sent. But if the user realizes the message is incorrect, they can cancel it. So it's actually a nice way of saying, instead of saying, are you sure you want to send this? It's I'm going to send this unless you tell me not to. So just Delayed Confirmation View helps with making that easier. So it uses the circled image view for the implementation of the circle, and that provides the set progress and the timer countdown as well. And to use, we have another thing called a confirmation activity, which is after the message has been sent, you can actually pop up a green checkbox to say it was done. So the green checkbox is actually an animated vector drawable that appears, and you can use this code here where you start an activity which brings this confirmation activity up on the screen. So you've seen all of these different things appear in Android Wear apps. This is how it's done. Also, we have a circled image view and a circular button. These are two different sort of more little clickable widgets that you can use if you want to implement pop-up boxes that show various things. So these are all useful for different kinds of apps that people might want to make. And remember also to use very large touch targets. You see those things are very large compared to the size of the emulator window I used there. You can only fit about 4 of those on the screen. You want to make sure they're really big. You don't want to have 40 of these buttons on there because no one's going to be able to press their finger on it accurately to be able to press it. Finally, we have what's called a remote input intent, where you can actually start an activity that brings up this remote input intent, and it allows you to take advantage of the speech recognition engine of Android Wear. So you can see there it says speak now. You can speak whatever you want. It'll transcribe the text for it, and it'll then return a string back to your app. Alternatively, you can press draw emoji, and you can draw an emoji, and it'll send you back the emoji as a string as well. So you can actually use emojis and speech in your app without having to implement all that stuff yourself. And Android Wear has a really cool emoji recognizer that you can use, and you don't have to write any of it yourself. So that's really nice. So that was a quick rundown of sort of the key features of Android Wear that are very important to writing apps. So let's just finish up by talking about voice actions, which are a key part of the platform. So as we mentioned earlier, we have this concept in Android Wear of, okay, Google, take a note, book me a ride, send a message, things like that. Those are system-provided actions that are task-based, they're built into the Android Wear platform, and they're specified with an intent filter. And you can actually hook into those if you want. So if you have an app that implements take a note, you can write an app that takes notes. However, if you've written an app that doesn't fit into any of the existing tasks that are built in Android Wear, you can also, the user can say, okay, Google, start app name, where app name is the name of your app as it's declared as the launcher icon in the Android manifest XML. So you can see here, you've got fit, keep, and can't read the last one, WhatsApp or something. You can say, okay, Google, start keep, and it'll bring the app up. So this is the way that your app can always be launched easily. The user can use their finger to launch your app, but they can also speak it as well. And then finally, we have the speech recognizer that we showed earlier, and that was the remote input intent. You can use that as well. So those are sort of the main ways you interact with an Android Wear device. It's not just about touching on the screen, it's about speech recognition and not thinking about your apps in terms of apps, but thinking about them in terms of tasks that they solve. Users want to take notes. They don't want to launch a note-taking app. And there's a difference in how you understand that. These are actually a list of the actions that are currently in Android Wear. So you can see there's a whole bunch of different things that you can do here, and those can change over time. So there you have it. So this is a summary of the ways that the different things you can use to go about creating Android Wear apps and the different things you can do. So we actually have a code lab that's starting at 12:45, I believe, where the code lab is all about creating your own watch face for Android Wear. So you can show up, we have a starting sample, you can drag your own image in, and you can create a watch face with a custom picture of your dog or your cat or whatever. And it's a really cool way of just sort of seeing how quickly you can get started with Android Wear on an emulator. And if you don't have one, you definitely need to go out and get one. They're really cool devices, and lots of apps on the Play Store now support them, and there's a lot of functionality that is sort of interesting for developers, and it's a great way of differentiating your app because there's a lot of apps out there, but if you have a really great Android Wear implementation, that might be the thing that makes your app popular amongst people and helps you to get a bit of a foothold with more customers. So if you want to learn more, I have a whole bunch of documentation on developer.android.com/wear. We have design guidelines on developerandroid.com/design/wear, where we sort of talk about more of the design methodology and how to make really beautiful apps. Google really cares about design right now, and so it's really important that you make nice apps that look really good. Don't just take old apps and sort of squeeze them onto the wearable display. You gotta really think about the user and do a really nice job about it. So I post a whole bunch of stuff on G+ constantly, so I'm one of the main developer advocates for Android Wear, so every week or so I put out tips and so forth about how to best take advantage of the platform, things I've discovered, new releases. So please follow me on Google+ if you're interested in learning more about the things that I do. And as I said, I talk about Android Wear a lot, but we also talk about Android Auto and ubiquitous computing. And also I will put my biscuits and gravy recipe up on G+ as well. So go check that out. So thanks very much for coming, and thanks a lot. And I'm happy to talk to you all later. Thank you. And I guess we've got a few minutes for questions if anyone wants to ask anything. You had a question? Yeah.
Anyway, thank you. So I have a question is when we do action button on the Wear,
Yep.
Like we swipe and then you push button on the grid view. Would that send the data, the signal, to the wearable alone, or it will send the data to the mobile or it will be able to do both? And
Okay.
how?
So the question was, is that when you press like an action label or a button or something like that, will the press? Oh, thank you. Which is, will the press get sent to the phone as well as the wearable? And the answer is no. So if the wearable created these buttons and widgets, the callbacks or whatever are only sent to the wearable itself. If you want the wearable to send something to the phone, you need to send a message or a data item or something like that. Now, in the case of notifications, if you create a notification on the phone, the notification appears on the wearable. If you click one of the actions, that will get sent back to the phone. So that's only done in the case of a notification, and it's only done in the case of if the notification is created on the phone. It's actually possible to create notifications on the wearable. Those are not sent back to the phone. So yeah, typically the wearable never sends anything back except for a notification created on the phone.
And is there any way we make it to send back, or it's just by
you have
default?
to write that mechanism yourself. So if you want to send something back, you do a data item or a message or a channel, and then you can send it back that way. Okay. Yeah. Next question.
One question. When we use the message API or the data API for devices that support Wi-Fi, they connect through the cloud, right? Is there any way to prevent that behavior? Like if we only want to send messages or data items only if they are connected through Bluetooth to avoid sending data to the cloud. Like, I mean, for a big company, it's important to have your data like secure, right? And we don't want to send data to other services.
So I mean, in the Node API, there's something you can, there's a method, I can't remember the name of it, but it basically is local or something. It's like given, so you can ask for a list of devices, and then you can, for each device, you can say, is it local or not? And that then would tell you if it's connected via a local pairing or if it's still available but it's connected via the cloud somehow. So that could be a way that you could avoid sending it through the cloud like that. But I mean, I guess there's a possibility that it could switch from Bluetooth to Wi-Fi mode and you could send the message just as it's making the transition. So there's no way to mark a message as do not ever send this to the cloud. At the same time though, messages in the cloud are not stored, they're just sent via it somehow.
I'm worried about the data API. Because data API, normally you push things into the network.
Yeah.
And then it gets synced across all the clients.
Yeah.
But because the cloud node is part of that network, there is no way to prevent that data to actually go to the cloud. But you still want that syncing behavior, but only if they are connected.
Yeah, in the case of data items, the thing is when you create a data items, it's synchronized to all devices automatically. I don't think there's a way to prevent that from happening. So yeah, if it was really important to you, I guess you could encrypt it. I don't know, you'd have to do something about that yourself. There's nothing to support that. Yeah. Any other questions? Yeah. Do you want to grab the mic? Yeah.
So I have an LG Urbane watch, so that has a Wi-Fi.
Sorry, can you speak up?
I have an LG Urbane watch, so that has like a standalone Wi-Fi in that watch. So whenever I make a network request, when it is not connected to my phone via Bluetooth, it works fine. But when it is connected to my phone via Bluetooth, the Wi-Fi is automatically disabled. So basically, I cannot make a network call if it's connected to Bluetooth via Wi-Fi in the watch.
Wait a minute, you can't make a call? What?
Like network call.
A network call?
Like via Wi-Fi.
Oh yeah, okay. So I mean,
like,
the thing is, the Wi-Fi
designed like that, or like what's the use case for that?
Yeah, so the Wi-Fi feature it uses more power than Bluetooth. So we want to keep Wi-Fi off when possible. So if everything's working over Bluetooth, we will send things over Bluetooth. Now, I think what you're asking is you've got an app that's running on your watch that's trying to make HTTP requests.
Exactly.
Right? Yeah. So you're not supposed to do that. So if you want to do network requests from the watch, you're relying on behavior that's not really supposed to be used. So what are you trying to request?
I was trying to develop some feature actually. I mean, I was just trying to verify.
So, I mean,
and all.
yeah, it kind of works. The problem is you can't keep the Wi-Fi feature on. You don't get to control that. So if Bluetooth is available, it'll switch to Bluetooth.
Okay.
So the correct way to deal with what you're trying to do is if you really wanted to make an arbitrary HTTP request. So if you want to check the weather, you send a message to the phone gets the weather,
Okay.
and then you parse all the HTML, you extract out the temperature information, send it as a
back.
data item.
So all the network operations should be done within the phone app,
Yeah.
and the data should be passed via the data API or message API to the
Yeah,
client.
and that'll work. Now, if you really wanted to get dirty, so the dirty solution is you send a data item to the phone that says http://weather.com, blah, 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 and then the reply is the entire HTTP response as a string. And then the wearable could do all of it. So you could write yourself a really cheapy little proxy over data items that go back and forth, or you could use the channel API, but you're really not supposed to be doing that. You're gonna be doing it wrong, and you're gonna be wasting a lot of power. So that's the solution if you really wanted to be lazy about it. But the best solution is get the phone to do the work and strip the data down into its simplest form and then send it back to the wearable.
Okay.
So yeah.
Thanks.
Okay, I think we're out of time. So we do have a code lab, remember, at 12:45. And actually my colleague, Michael Kwan, he's giving a talk at 12, I think. He's giving a talk. He's actually one of the engineers on Android Wear who did a lot of work on power optimization and looking for bugs. And he's a fantastic engineer. So you definitely, if you're interested in Android Wear, you definitely want to hear Michael's talk as well. Otherwise, I'll be around at 12:45 at the Code Lab room talking about Android Wear watch faces. Feel free to come and talk to us then or during the barbecue afterwards. And thanks a lot, and I'll see you later. Thanks.